If you see the silver electrode, so silver electrode electrolysis of electrolysis of aqueous silver nitrate. This is aqueous silver nitrate using silver electrode. So we are using aqueous silver nitrate and silver as the electrode. So again you take the beaker, in that you fill with the silver nitrate solution, aqueous solution. So this contains the silver nitrate aqueous. I am telling the aqueous, that means water also present, and silver nitrate salt is going to break into the Ag plus, NO3 minus, and H plus and OH minus. So this is happening, and if you take the electrodes are here. One is positive electrode and one is negative electrode. Negative electrode is the cathode and positive electrode is the anode. So what happened at the anode and what happened at the cathode? If you see the anode half cell reaction and cathode half cell reaction, so silver is going, if you first see the cathode means negative charge. So negative is electrode, that is silver is acted here inert electrode means there is no here silver is the inert electrode, inert electrode, that means there is no reaction with the silver plus ions. So according to the discharge potential theory, if you see discharge potential theory, silver plus is having least discharge potential compared to the H plus. So this between silver plus and H plus ions, silver plus ion go to the electrode, and silver plus ion go to the electrode, and silver plus get into reduction, and it gives the silver on the silver plate. So here silver act as a inert electrode, but at anode what will happen, there already it is the solution becomes NO3 minus. So in solution already silver is gone there, that means NO3 minus ions were present. So NO3 minus ions easily react with this this OH minus and OH minus, here at anode the silver is going to be at a silver plus electrons. Here silver thickness will be decreasing because here silver into the solution, so silver is going to be silver plus electron. Here it is a active electrode, silver act as a active silver electrode. So the net reaction will be like this: silver is going to be silver plus and silver plus going to be silver. So there is no change in the concentration of the reactants or product. So during the here notable point is during the electrolysis there is no change in the concentration of electrolyte is constant, remains constant. So if you see here the both silver act as a active electrode and inert electrode. Inert means which do not react with the react with the another metal. So here it is the electrolysis of the silver nitrate by using silver electrode. So again if you see the sum of the electrolytes you can take. Remember this table, definitely you will be do good in your competitive examination. So electrolyte and what is the electrode we took, that mainly gives, and reaction at anode. So reaction at anode and reaction at cathode. So reaction at anode and reaction at cathode. So what is the electrode we have to electrolyte solution? Electrolyte means there is a salt and which is in the form of fused state or aqueous state. So first we take the fused NaCl fused NaCl, that means electrodes. Electrode is a platinum electrode, that means inert electrode. Whatever the solution is there, that one goes to the anode and cathode. So fused NaCl means it has a sodium plus ions and Cl minus ions, and here you are taking that Na plus Cl minus, Na plus Cl minus, Na plus and Cl minus. So at anode is oxidation. Anode is oxidation, that means Cl minus is going to be half Cl2 plus electron, half Cl2 plus electron. Next, sodium is going to be sodium plus electron gives rise to sodium metal. Deposition takes place at the cathode. And if you take the another example is aqueous NaCl. Aqueous NaCl, this means pure NaCl. This is liquid form of NaCl. Aqueous NaCl, if you take the platinum electrode, so aqueous means there is a competition between the sodium plus and H plus. Here is the sodium plus and H plus, and here is the Cl minus and OH minus. So discharge potential is lesser for the Cl minus ion. So here also Cl minus is going to be of Cl2 plus electrons, and here is the competition between the H plus and sodium plus. So obviously H plus is the least discharge potential compared to the sodium plus, so electrons will give you the H2 gas. So here 2 H plus 2 electrons gives rise to H2 gas. So next thing is fused NaOH. Fused means there is a solution NaOH. It presents of platinum electrode. So platinum electrode, that means Na plus OH minus. So obviously at anode OH minus is going to be gives oxygen. Oxygen plus 4 electrons plus 2 H2O plus here is the 4 OH minus ions, and at cathode sodium plus, and sodium plus is there, so sodium plus taking electrons gives rise to sodium. So this is the reaction at cathode. Next thing is if you take the aqueous NaOH, so aqueous NaOH. So aqueous NaOH and platinum electrode, that means NaOH will have aqueous solution, means competition between the H plus OH minus is there. So obviously OH minus ions, 4 OH minus ions gives rise to 2 H2O plus oxygen plus 4 electrons, and here competition between the H plus and Na plus. So H plus Na plus, H plus is the least discharge potential, that means this electrons 2 H plus 2 electrons gives rise to H2 gas. So next thing is if you see the aqueous NaOH and aqueous HCl. So aqueous HCl, that means platinum. So aqueous HCl means there is a competition between the Cl minus and OH minus. So Cl minus OH minus. So Cl minus will the least discharge potential. So it going to be half Cl2 plus electrons, and here is the H plus ions and H plus ions. So H plus ions will going to be 2 H plus 2 electrons gives rise to H2 gas. So H2 gas. So next thing is aqueous Na2SO4. you can take Na2SO4. So aqueous Na2SO4 means there is a competition between the sodium plus ions and H plus ions, H plus and sodium plus. Which one is the least discharge potential is the H plus ions. So 2 H plus 2 electrons gives rise to H2 gas. Next here the reaction at anode is competition between OH minus and SO4 2 minus. So OH minus, obviously 4 OH minus gives rise to 2 H2O plus oxygen plus 4 electrons here at anode. Next thing is if you take the copper sulfate, platinum electrode, aqueous copper sulfate and platinum electrode. That means here you have the copper 2 plus and aqueous is the H plus. So which one having higher reduction potential, this discharge potential is the H plus, and copper plus 2 is the least discharge potential. So copper 2 plus 2 electrons gives rise to copper. And at SO4 2 minus and OH minus 4 OH minus. So it gives rise to 2 H2O plus O2 plus 4 electrons. Here the competition between the OH minus ions and SO4 2 minus ion, because aqueous is there, so H plus OH minus as ions also present. Next, here you can take the aqueous AgNO3 or aqueous AgNO3, aqueous AgNO3, and here it is, you can take the platinum electrode. Platinum electrode, that means you are taking the platinum electrode. Platinum, that means inert electrode. So here silver plus NO3 minus is there, and H plus OH minus. So competition between the silver plus and OH minus. So obviously NO3 and OH, if you see OH minus is a low discharge potential, so obviously reaction will take place at the anode will be with the OH minus ions. At cathode, which reaction it will take? Ag plus electrons gives rise to silver. Electron, it gives rise to silver. Next thing is, if you take the aqueous copper sulfate, and here is the copper electrode. If you see the copper electrode, copper means it at anode, copper is going to be oxidation, that means copper 2 plus 2 electrons, and here is the copper 2 plus 2 electrons gives rise to copper. And aqueous silver nitrate and silver electrode. Silver is going to be silver plus electrons, and here silver plus electron gives rise to silver. So this is the when we take the silver electrode, this is the reaction. When we take the platinum electrode, this is the reaction. So silver nitrate, and this is the difference between platinum electrode and copper electrode. These four are very important for the competitive examination. Thank you very much.